Hi, I thought it would be helpful to give you something of a brief introduction to the CPRE 381 labs. Things are a little bit different with using the remote VDI infrastructure, and this will just be a very brief overview. You have your TAs who can help walk you through some of the individual steps, especially if you get stuck. As I mentioned, the VDI is a little bit different, a little bit new this semester, so that is really your first starting point. And I provided the link in the assignment itself, but that's where you're first going to want to go, which is to the department's main page for downloading. It's under remote access for the department's ETG website for downloading the VMware Horizon client. There is a way that you can connect via just your web browser. You're going to want a pretty stable, consistent connection, so I do recommend that you do download this natively. A question that's already come up that I think is a perfectly valid one is we have all this remote infrastructure. Do I, as a student, do I have to use it or can I use my own infrastructure? Another way to phrase that more succinctly is I already have Modelsim installed on my laptop. Can I just use that? And the answer is absolutely yes. There's nothing wrong with installing any of the tools we use this semester just locally on your own workstation or on your own laptop. You're perfectly free to do so. There are many different versions of Modelsim out there. For the purposes of this course, they're all roughly the same. They're all perfectly fine to use. I'll add the slight caveat that if you're having some technical issue with your model sim, our support's probably limited to the VDI version or the exact version that we have installed here on the VDI. If you're having troubles with the license or something like that, that's something you can work out on your own. But if it's with our own install, we can certainly help you with that every step along the way. So there's a process here which I won't click through, in which you download that client, you install it, you connect to our Windows infrastructure, that VLab infrastructure that we have here for doing so. And then you would connect to one of many possible remote resources via that. And I'll open that up real quickly. So I have it installed here. I'm going to connect to vlab.ece. You would log in with your NetID and password. You don't have to be connected to the VPN, at least as of today, to access the VDI. It can still be a good idea to do so if there's other departmental or university resources that you want to access at the same time, but it's going to log you in like you're remotely connecting to a Windows machine, and that is what's happening here. When you first log in, there are a few different types of servers that are listed there. The one you want to connect to for this course is called CPRE Labs Virtual. There's also one that's physical that connects to actual physical workstations in Coover Hall. For our purposes for this semester, there's no need to connect to that. We're not physically connecting to any hardware, so we don't actually need to do that. So you log in, you should have a desktop that should look like your desktop as if you were physically sitting in Coover, including things like the number of printing credits you have remaining and things like that can pop up. For me, I have Modelsim just saved as a shortcut on the desktop. Otherwise, you can navigate to it in Windows or type it in the search bar and find it that way. I just wanted to open up Modelsim, very briefly give you some brief pointers. This first initial lab, we're not doing all that much with Modelsim. We're really just getting started, making sure that everyone can access all of the tools that we have here. So Modelsim is going to start up. We're up to version 2020.2. It is nominally the same as version 1993.1, but it is the most up-to-date version that we do have access to. I would click Don't Show This not very helpful dialog ever again to get started here. Let's make sure I have my mouse cursor here. So click Don't Show that dialog again, and then we can close out of that. And here is your main Modelsim window that you'll be starting with. Modelsim, like a lot of these design automation tools, is really just a GUI on top of a scripting engine that's automating all these underlying kind of one-off utilities to compile your code, to analyze your code, and to run simulation for your code, and then to display the results back out. And Modelsim, like a lot of these tools, makes that scripting engine that lies underneath the GUI very obvious. The window is kind of shrunk down a little bit here on the screen that we have here, but in my opinion, This is a very important window. So you get to move all these little sub windows around. You can accidentally lose access to stuff and get back to it. It's giving me a file error, but that's okay. This is the transcript window in Modelsim. I think it's pretty important. In the transcript window here, um, this is where it will show you the equivalent of what the script input would be to run any given command. There's also both in the menu layout part of the GUI as well as in these million little somewhat indiscernible icons that are up here on the screen, alternate ways to do the same exact thing. So a very common approach to becoming proficient with ModelSim is to first dig your way through the GUI to figure out how to do something specific. Either the lab is telling you to do so or you just know you have to do something in the tool. And then to look in the transcript window and see what is the command equivalent for that GUI that we're trying to do here. And the first example we can start with is the directory that ModelSim is running out of is actually pretty important. So even though we've opened it up, I actually want to make sure I run it in a directory that corresponds to where I have my files for lab number one. There are many ways to do that. One way is to go from the file in the menu to change directory, and you will want to do this. I put a directory on the desktop. I called it CPRE381 temp, and I'm going to change directory to that lab1 folder that we have there. There's lots of different places you can put your files for this course. I would recommend, your U drive or somewhere where you know you're going to be able to access that file multiple different ways. There's nothing wrong with using GitHub and things like that and collaborating eventually in that mechanism. Just making sure you just don't lose files because they were put in some random temporary directory is pretty important. This is on my U drive right now, the desktop for that particular machine. And we can actually see the equivalent command to changing that directory via the GUI. I would argue it's probably easier via the GUI because then otherwise I'd have to remember this entire path that corresponds to my U drive's desktop and that subfolder that I created there. There's a number of VHDL files in that directory that are already partially completed for you for lab number one. So what we can do here is then also go ahead and compile that as well. So in the GUI, we go to compile, and then we would navigate to the actual source file corresponding to it, and let's just compile that adder.vhd. You haven't even looked at the code. This is not a video trying to tell you how to do lab number one, just navigating through the tools. And you hit compile, and you can see kind of hidden in the background is what actually happened in the transcript window. Both the command, which eventually you'll get pretty comfortable with that command. It's not doing that much. vcom, VHDL compiler, report progress, some sort of debug output command, dash work, where do I want to put my output files? This does become important. Work is kind of a default name we tend to use. And then the actual name of the file that we're compiling. That is the command. So if I wanted to compile this file again and I didn't want to navigate all the way through the GUI, I can then just copy paste that line and can just run that whole entire command again. And then what happens afterwards is the debug output of that command to compile that file. In this case, it's not really saying that much. It's loading some packages, 0 errors, 0 warnings. All dark text in the window in your transcript is generally a good sign. If I were then to go and compile another file that intentionally is left incomplete for lab number one with some syntactical errors in place, I should get some errors back out. And we do that compile, and you start to get things like syntax error near that comma. But even that error can be somewhat verbose but helpful. In this file, specifically on line 73, we can talk about that at a future time, near line 73, near that comma, there's a syntax error, and you can then can click on that file, double click on that error message, and it'll actually pop up that file for editing using the Modelsim editor, and you can actually then see that, well, yes, there's some blank things there. That's why it's complaining about that compiling error. Once you've successfully compiled things, the next step is to simulate. There's a lot of ways you can do that. You can say, I want to do some simulation under simulate. You would then navigate to that work directory that was created and choose the module you want to simulate. and hit OK, you can think of this as two separate modes of Modelsim. The first being kind of the editing files and the compiling phase. Only once everything compiles to your satisfaction do you really move on to this next phase. This is the simulation phase. And inside this simulation phase, and we can close out of this file right now. Inside this simulation phase, it gives you a different view of the structure of your system, specifically what libraries and modules are loaded, what objects it can find inside this. And don't worry, if this is new, this is totally different, but it's all available here. And again, just like in the main window, you can actually go and view every single thing in here with an equivalent command in our transcript window. In this case, scrolling to the transcript window has the old errors, but we go down here, it successfully loaded the module in simulation. I've now asked it to view in my waveform diagram all these signals in my design. I can then specify things like, well, this is a clock signal. I want to actually have it act as a clock. We'll have it act as a 10 megahertz clock with a 100 nanosecond period here. You can see the command associated with that. We have two inputs that are actually integers. We'll force them as just values. We don't have to use hex. We can just say 7 for as a decimal value for A. We'll do 5. And here we see the equivalent command. As opposed to having to navigate the GUI over and over and over again, we can actually just copy paste that command. And instead of forcing A, let's force B to a value of 5. That extra number there corresponds to how much delay until we actually force that value. And then we would tell it to actually run for a period of time. There's a lot of different options up here. This is one that would run for that 100 nanoseconds. And we can run it for a nanoseconds. And eventually we add 7 plus 5, and we get a value back out of C as expected. And we can see the equivalent command is just called run here in that window that we have there. So with all those different commands, there's no doubt that there's a lot of complexity going on in Modelsim. And I don't expect you to know it all, certainly on day one. Um, our job in this class is to learn about computer architecture and digital hardware design, and Modelsim is an industry standard tool for simulating digital designs. You will get better with it over time, but the goal of this course is not for you to struggle for hours on end with compile errors in VHDL or Modelsim errors as it's trying to simulate something and throwing up an error there. Definitely use the resources available to you as you feel you're getting stuck and frustrated with things. We're using Discord this semester. I'm going to be very active on it. When you get that red text of an error, or later there's a subtle blue text that doesn't say it's an error, but basically is also an error, let us know. Try to fix it yourself, of course. Some things are very quick, but there's really no either syntactical or conceptual errors in this course until perhaps the very last couple weeks of the semester. That should be more than 5-minute bugs. There's not meant to be multi-hour bugs in this class. That is not the point. Definitely it takes time to gain that understanding of how to use the tool appropriately. When the TA helps you and you'll see they click, 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 and everything works perfectly, or I just provide you a script and everything just works magically, you'll get to that point eventually. It takes some time to get to that level of comfort. But none of the errors that you're going to encounter, and you will, both syntactical and logical and just tool-related errors, none of them are meant to be showstoppers that are meant to frustrate you for hours on end. So big takeaway from today is connect to the VDI. That's my recommended way of doing so. Modelsim is a complicated GUI on top of a very simple little scripting engine that you can then use directly versus even really using the GUI. And definitely reach out when you're stuck with something. And I'm very happy, the TAs and I are very happy to help when that happens. Okay, good luck in this lab, and let me know. Thanks.